Hello everyone, and I welcome you all to another video of our string series. All right, and in this video, we are going to look at one of basic problems called anagram. All right, and in this video is going to be very important because we are going to learn a very important trick, or you can say algorithm, which we use to solve most of the string questions. All right. So make sure you watch this video till the end. Okay. So, okay, let's start. First of all, let's read the description. So, description goes like given two strings A and B consisting of lowercase characters. All right. The task is to check whether two given strings are an anagram of each other or not. So, an anagram of a string is another string that contains the same characters. Okay. So, let me tell you what are anagrams in a more simpler language. Suppose I have a string A, B, C, D. All right. Now, if I like have to define the anagrams of this, so I'll just basically say permutations of this string B, A, C, D, C, A, D, B, A, C, B, D, and yeah, many. Wait a minute. Okay. Yeah, and many more like this. Okay. So suppose I have one string s1 and one more string s2. It is like some string like this. So how can I say s2 would be anagram of s1? Simply I can say that frequency of characters present in string 1 and frequency of characters present in string 2 should be equal. Suppose a frequency in this string 1 is 1, so frequency of a should be 1. Frequency of b is 1, so here also the frequency should be 1. Okay, that's cool. Let's erase this a little bit. Let's leave one anagram and leave the rest. All right. Now, first, let's talk about the brute force approach you can apply here. You may like pause the video and think on your own like how to solve it. Okay, first of all, let's talk about the nice solution. So here we have two strings, right? This is s1 and suppose this is s2. So if I say I sort both of these strings, so after sorting A, B, C, D, the sorted S1 would be obviously A, B, C, D, and sorted S2 would be A, B, C, D. And I can simply compare these two. And if both, if the comparison, like if we compare it and if we uh, get the comparison result as true, the output would be true, otherwise it would be false. Okay, so let's just simply write it here. So I'm going to use the inbuilt sort function provided by C++. So if you don't know how to use it, let me tell you. So basic syntax goes like you just write sort, okay, and then you write what you have to sort and from where to where. So I have to sort a string A from its beginning to end. So I'll just return A dot begin, A dot end. Okay, I'll write sort P dot begin, comma P dot end, and simply I'm just going to return A is equal to B. Is that correct? Let's check it. Let's compile and run. Let's see if it works. Okay. Okay, what are we doing wrong here? Hmm. Okay, so b dot begin, we forward the parentheses. Let's see and compile. Let's see if it works now. Okay, it is working. Let's try and submit it. Okay, we're getting a correct output. So let's talk about the space complexity here. So space complexity used by a sort inbuilt sort function is big O of number of characters. Say number of characters is n, so it would be big O of n. And time complexity used by the inbuilt sort function is n log n. Okay. Now we'll think of a better approach, which would be like reducing our time complexity here. So can you like think of doing this question in time complexity of n? Big O of n. Okay, let's erase this and now we'll talk about the efficient solution, which will use the algorithm which I mentioned earlier in this video. So let's quickly see what it is all about. So I can suppose I have a string of, I have a array whose name is char. Okay, and it okay, and it basically like contains what exactly here? It would be containing the the frequency of elements, frequency of basically letters in a word. Are you understanding what I'm trying to say? Okay. Let me tell you by giving an example so you will understand better. Suppose I simply have a char of 256. Okay, you might be wondering why I'm using 256 because see, when we are dealing with letter, so we generally have, if we want to like, uh, you know, basically, what do we say that word? Yeah, if you want to like convey a letter, okay, in terms of numbers. So we'll it can be done using ASCII code. Okay, so I'll repeat what I just said. That if a letter, if we want to represent a letter in terms of numbers, we'll be using ASCII codes, right? So if you don't know about ASCII code, so it is basically like every letter like A, capital A, B, capital B, these are given ASCII codes. So A has some ASCII code in numbers, capital A has some ASCII code, capital B has some ASCII code in numbers. So the maximum ASCII code of a letter is 256. That's why I use an array of 256 here. Okay. So yeah, we have a character array of 256 and all the entries are 0 currently. Now suppose I have a string s1 AABC. Okay. So see, I come across A, right? So what I'm going to do is that I'm going to increase A's frequency in my character array by 1 and rest of the elements are 0. Then I again see A, I'll again increment its frequency by 1 and rest of the elements would be 0. When I come across B, I increment it. Okay, now I come across C, I'll increment it and rest of the elements are 0. Now suppose there is another string and if I have to check whether this string is anagram of this string, what I'm going to do? I'll come across this first letter, it's B. So I'll just reduce its frequency in my character array by 1. That means 0. I come across A, I'll decrement its frequency by 1. I come across C, so decrement. I came across this one, I simply decrement. Alright. And after doing this stuff, in the end, what we are just going to do is we're going to check if all the entries in our character are 0. If they are not, then both the strings are not anagram of each other, and if it is 0, that means both are anagram of each other and we'll return true. Alright. So let's try and code this thing so you'll understand better. Let's remove the stuff. Previous code. Now we'll have const int char 256. Right. We'll have a check if a dot length not equal to b dot length. Simply return false. Obviously. Now we'll have a array called count. Yeah. And it is going to be 0, all the elements. Now I'm going to have for int I is equal to 0, I less than a dot length I plus plus. What I'm going to do is I'm going to increase for a letters in string a and decrement for letters in string b. Okay. Now what I'm going to do is we are going to check if all the elements are 0 or not. So if count of any element suppose is not 0, we are simply going to return false, and if in the end we'll just simply return true. Okay, let's try and run this code. Okay, so we are getting a correct output here. Let's try and submit it. Let's hope it works. Okay, so yeah, it works. So in this video you learned about an algorithm basically where you declare array of count where you store the frequency of all the elements present in a string. Alright, and remember this number, you have to create an array of this size only. Alright, so I guess that's it. That was it for this video, and if you have any doubts regarding this lecture you may ask your queries in the comment section. And yeah, that's it, and we'll see you in the next video. Thank you for watching.